Hey guys, in this video I want to talk to you a little bit about our teaching methodology and curriculum development and sort of the ideas behind why we do what we do. So many of you have probably noticed our main math curriculum starts with this worksheet over here, Math Paths, actually this one, M0, right? Math Paths, the rite of passage and the trial by fire. And that's a whole bunch of like fancy and exciting language, and we give a bit of a pep talk, right? But what's the idea behind this? On this particular worksheet, it definitely starts out, you can see with, okay, we're testing distribution, we're testing factoring, we're testing graphing, we're testing the ability to subtract complex fractions, right? So any arithmetic issues are going to come out in question 5 for sure. We're testing, do they remember like systems of equations? Do they remember how to substitute? Do they remember any of this stuff, right? So it's a lot of basic algebra. And then we're going to get into some pretty complex questions over here, right? So we've got this thing where you have to use factoring as part of what you're doing. Then you have to use substitution. But it's not as straightforward, right? It's not a question that just says factor this. It's a question that involves factoring but doesn't tell you what to do. And that's sort of the goal of this question, is really to get you in a mindset of, you know, I'm going to need to have skills, and then I'm going to need to be willing to test them out. I'm going to need to be willing to just try stuff. I'm going to need to be willing to take risks, take chances, right? And that's a bit scary for some kids, absolutely. But the goal really mainly being that we want to get kids to that place because they can't do complex math problems if they're not willing to try stuff, if they're not willing to just throw things at the wall and see what sticks, right? All of us as instructors, we do this all the time, right? Because we've done a lot of advanced math, and so throughout all of advanced math, we're just like, well, gosh, I mean, maybe this is okay. And you're just sort of trying things, right? And then something sticks, and you're like, oh, hey, that's pretty cool. And that combined with, I would say, intuition, right? Over time, we develop this intuition that says, hey, you know, maybe it's more useful to have a fraction instead of a decimal in this case, or, you know, an exponent instead of a radical, or whatever kind of a thing. And that's pretty nice. Then we go on, right, and this worksheet gets into, so this is more factoring, more substitution, really sort of reinforcing that same skill. This one, quite a bit more complex, right? This whole like triangle. Now we're juggling a lot of pieces of information. We need to get the student to realize that sometimes you're going to have to go back to the information in the question multiple times. You're definitely going to always want to draw a picture, right? So that's like a really, really critical thing. It's like a thing to teach the student, right? So who cares about the question, right? Whatever. Maybe they get the answer and it's fine. I think this answer is 224, but who cares, right? What does the number 224 mean? Nothing. The point of this question is teach the student that you should always draw a picture. Always, 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 right? I mean, like forever and ever. And remind the student that you yourself, as an instructor, you are super good at math and you still draw a picture, right? Obviously you draw a picture because being better at math reminds you that, hey, by the way, you definitely really need a picture for this thing, right? And so reminding that student, I tell students all the time, I always draw a picture. I always write out all of my steps. I always do all of my steps in one single vertical column, and I tell them that. Because it's very important, right? If you have a mess of nonsense, you're going to get it wrong. And I know that, because every once in a while I start to have a mess of nonsense, and I have to restart because I'm going to get it wrong. So these are the types of things that we want to communicate with the student, right? In this particular question, definitely drawing a picture, super huge. Revisiting the question multiple times, also starting from the thing that you're solving for, right? So sometimes you need to start at the end and work your way towards the middle, and start at the beginning and work your way towards the middle, and you're going to meet in the middle. Students are not really used to this, right? So this is like a totally different mindset. This is the thing that I teach them in this question, right? Sometimes you don't always start at the very beginning and just go straight all the way to the end. Boop, boop, boop. There you go. Done. Sometimes we start at both ends, right? And we say, okay, well, we have this information. So with that, you know, first sentence, I'm going to draw a picture. And with the second sentence, I'm going to, you know, maybe write a little equation. And the third sentence, I'm going to, you know, edit my picture. And then with the fourth sentence, now I'm starting at the end and I'm going to manipulate the thing for which I am solving. Right. Well, now that's like a whole different idea. So there's different ideas of things to like teach from a lot of these questions. Obviously this next question, this is like our biggest kind of exciting, crazy question. This one stumps a lot of people, right? There are a lot of easy mistakes to make. And it's a wonderful question to just sort of remind the student, hey, by the way, you know, don't assume anything, right? And obviously it says figure not drawn to scale. Okay, we know that. But I mean, but yeah, we're always going to like kind of be like, well, what if RC was 4 and C2 was also 4 and then RA is 7 and SA is 1? Or, sorry, 5 and 1 and then 3 and 3. I thought that was 8, but yeah. But that's kind of like always the desire, right? Is to say, okay, well maybe RC is equal to CT, but it's not. Well, it certainly isn't, right? They're probably very close, actually, in decimal numbers, they're very close, but it's not exactly equal. And we know for a fact, right? We can prove that for a fact by doing the Pythagorean theorem once we've solved for AC using the other methodologies that we have in this question. But so that's like a really important and critical teaching moment as well, right? Is to say, hey, you know, sometimes it's really, really wonderful to like think in your mind, like, wouldn't it be so great if RC was 3 and AR was 5? Like, that would be so awesome. And then I could just solve for AC, no big deal. I know Pythagorean theorem. And it's wonderful that they're thinking about the Pythagorean theorem. But we do need to like make sure that all of the information that we're operating on is completely and 100% provably true. You know, it gets a little bit into geometry, but just sort of approaching it from a perspective of, hey, you know, the figure's not drawn to scale. The figures are never drawn to scale on the SAT. Do not trust the scale of the picture that's drawn. So we've got, you know, kind of things like that. And that about wraps up, right, M0, at least, over here. And then, you know, if you've been through any of the Math 2 curriculum, we also have a lot of these really complex questions. This first question on MathPaths requires you to convert radicals into exponents and then to use the multiplication exponent rule, right, to combine them all, and then to recognize that all of the combined exponents now create an infinite geometric sum, and then to recognize that, and then to know the geometric sum information, and to use that to solve for the sum of just the exponent, and then to remember, by the way, that there was a base along with that, so it's got to be, 3 to the power of whatever, and then just the concept of understanding, well, what is this even saying, right? As n approaches infinity, find the limit of this product, and you know, just the concept of limits and being able to like literally read this question, right? It's a hard question. So culminating here, right, a lot of things that I can teach you about some of these individual worksheets, individual questions, but why do we start, and this is the big question, why do we start the curricula with such a hard worksheet, right? Such a crazy difficult worksheet, such a hard collection of questions. And the reason is like there's a couple of reasons. We want to definitely be able to trigger as many drop-downs as we can, right? So as I mentioned at the beginning of MathPaths, we're trying to trigger any like graphing issues, any basic algebra issues, any forgotten arithmetic, like all of those sorts of things, which happens all the time in all ages of students. We do want to trigger those as fast as possible. And we have drop downs for all of those things, right? So that's kind of our goal. But then additionally, right, so in this next level, now we also want to, like, as quickly as possible, get the students in a place of recognizing that, you know, math is not all about, it is not in any way about doing the same thing that you know how to do, like, infinity times, and being bored. Like, that's not what math is, right? Math is a puzzle. Math is figuring things out. Math is exploration. Math is taking those risks and saying, gosh, I don't know, but let me just throw this at the wall, right, and see what sticks. And so really trying to just very fundamentally redefine the way that they think about math, because most of these students come in and they think, oh yeah, math is where you have an equation like x plus 5 equals 9, and then you subtract 5 from both sides, and then you get the answer. And then you go to the next question, which is x plus 3 equals 4, and then subtract 3 from both sides, and you get, and that's not like just doing the same thing on repeat. It's good for practice. We all need practice, right? We all had to practice our multiplication tables. That's fine. But we all don't sit around as advanced math people and, you know, remind ourselves what 2 plus 2 equals. That's not what we do, right? Because that's just not what math is, right? So understanding that all of those basic things are the building blocks. 2 plus 2 is the building block. It's not the math. That's not the math, right? That's not the concept. The idea of math is that it's a puzzle, it's a challenge, it's a struggle, it's a beautiful struggle, and trying to communicate that as best as we can to students. So if you get to this point, right, where you're just looking at these worksheets like, oh my gosh, I can't believe that worksheets number 0 and 1 in the math curriculum, are so full of these crazy challenging questions. And then, and same for math too. If you get to that point, this is sort of the answer to that question. Let me know if you have any questions about this, and I will see you in the next video.